Numbers are of two types. There can be rational numbers and there can be irrational numbers. So rational numbers, firstly, are such numbers that can be written in the form of P upon Q. That means that rational numbers can be written as fractions where the Q or the denominator should not be 0. Okay. So the second thing we should know is that rational numbers, when solved like in the form of P upon Q, they will either give us terminating numbers or they're going to give us repeating numbers. So terminating numbers, let's take an example, 1 upon 2, right? When we solve this, we'll get 0.5. So this number came to a point and it stopped, right? So we're saying that 0.5 is an example of a terminating number or a terminating decimal. Okay, so the next type of question we have is 1 upon 3, right? When we solve it, we'll get 0.333 and this 3 is going to repeat itself, right? So 0.33 and so on is an example of a repeating decimal. So these sort of numbers and these sort of numbers are both going to be rational numbers. Okay, so repeating numbers can also be seen like this, like it's going to be like 0.678 678, like the same digits repeat themselves, right? So it can also be a larger set of numbers that repeating, like 0.7142 7142, right? So the same numbers are repeating themselves. So these all are rational numbers because these all are forms of repeating numbers. Okay, now we should also know that rational numbers can be all integers, right? All negative numbers and all positive numbers, they're all rational numbers, and all of the perfect roots, right? So all perfect roots, for example, under root 36, right? So that will give us a 6, right? So all perfect roots are also rational numbers. Now, irrational numbers are going to be the opposite of rational numbers. First of all, they can't be written as fractions, right? So they are not going to be written as a fraction. And the second thing is that these are such numbers that don't terminate, they do not stop, or they do not repeat a certain pattern. So an example of it is pi, right? Pi has a value of 3.142 and so on. So we see that the numbers, the decimals, are not giving us any pattern. Also, they're not terminating at a point, right? So such numbers are irrational numbers. And the second example of irrational numbers are imperfect roots, right? Imperfect roots. For example, we have under root 3, right? So this is not a perfect square. So this is an irrational number. So when we write imperfect roots, right? So we can also call them surds. Okay, so surds are irrational numbers written under a root in the form of an integer, right? So we see that 3 is an integer, but under root 3 is actually a surd. It's an irrational number. Okay, now let's look at some questions related to rational and irrational numbers. First of all, we should know how to identify irrational and rational numbers. So the first example is 12.77, right? This comes to a point and stops. It terminates, right? So obviously this is a rational number. Then second question is minus 36. So minus 36 is a negative integer. So this is also a rational number. The third question we have is under root 27. We see that this is not a perfect root, so obviously it's a surd. So all the surds are irrational numbers. Okay, the next question we have is under root 500, right? This is an imperfect root as well, and if you plug it in your calculator, you'll get around 22.360 and so on, such numbers that are not terminating and not repeating. So this is also an irrational number. Now the last question we have is a fraction. So the first thing I told you that fractions are rational numbers, so this is also a rational number. The next question we have is addition and subtraction of irrationals and rationals. So we should know that, I'll just write it over here, if we add an irrational number to a rational number, the answer we get is always going to be an irrational number. And if we add a rational number to a rational number, so this is also going to be a rational number. And if we add an irrational number to an irrational number, that is going to be an irrational number as well. So we see in the first question we have under root 3, which is a surd, and a surd is an irrational number, and 6 is a rational number. So I said that irrational and rational will always give us an irrational number. So we don't have to solve over here, they just asked us to identify, right? So for the first question, the answer we're going to get is going to be an irrational number. The second question we have is under root 3 plus 6, right? So we're expected to solve this first. So this is going to be an under root 9. Under root 9 is a perfect square which gives us the answer 3. 3 is an integer, so obviously this is a rational number. Now the last question we have is an under root 64 and a cube root of 64. Under root 64 is obviously 8, right? And the cube root of 64 is going to be 4. Okay, so these both are rationals, right? This is also rational and this is also rational, which will give us another rational number, which is going to be 12, right? So this is, we don't have to solve over here, we just have to tell if it's going to be a rational or irrational. So obviously it's going to be a rational number. Next type of question will be given is going to be proving that a certain number is smaller and bigger than some number, right? So this is an irrational number between two integers. So what we'll do over here first is that we'll find the cube roots of 6 and 4. So 3 multiplied by 3 is 9 and 9 multiplied by 3 is 27, right? So cube root of 27 is smaller than the cube root of 41, and the cube root for 4 is going to be 64 because we just multiplied it for 3 times, right? We'll get 64. So what we just did over here is that we proved that under root 41 is smaller than cube root of 64 and it is greater than cube root of 27. The last question we have over here is cube root of 800 is larger than 9 and smaller than 10. So we just multiply 9 3 times and we'll multiply 10 3 times. So we'll get a cube root of 1000 over here. And you can simply do this, like under root 3 is 800. And the last one we're going to have is cube root of 729. Okay, so we just proved that 800 is larger than a cube root of 729 and smaller than 1000. So now the last type of question is finding a rational number between two integers. So first of all, we'll write both of these numbers in their square roots, right? So 2 2s are 4 and 3 3s are 9. So we have to write a number between 4 and 9. We can just write under root 5. So under root 5 is an irrational number between 2 and 3. Now the second type of question, we have 1.4, right? So we'll just simply multiply 1.4 twice and then we'll get 1.96, and then it's going to be 1.5 multiplied by 1.5 is going to give us 2.25, and then we have to write a number between them. So we can write a number between them. We can say 1.97 is an irrational number between 1.4 and 1.5.